Peace be unto you and to your family. 11th Chemistry, Unit 2, Quantum Mechanical Model of Atom. In this we are going to discuss about important questions from question number 26 to 33. Question number 26 is, which quantum number reveal information about the shape, energy, orientation and size of orbital? Among the four quantum number, shape of the orbital is explained by azimuthal quantum number L value. Orientation of orbitals explained by magnetic quantum number M value. Energy and size of the orbitals are explained by principal quantum number small n value. Come to question number 27. How many orbitals are possible for n equal to 4? Principal quantum number equal to 4, fourth energy level. N equal to 4 means L have 4 value 0, 1, 2, 3. L equal to 0 means M equal to 0 because M value depends upon L value. M value equal to minus L, 0 up to plus L. M equal to 0 means there is only one orbital. In the fourth cell, S orbital is present. L equal to 0 means S orbital. L equal to 1 means there are three possible value, minus 1, 0, plus 1. Therefore, there are 3 p orbital, L equal to 1, 4px, 4py and 4pz. L equal to 2 means the possible M values are minus 2, minus 1, 0, plus 1, plus 2. There are 5 orientation for d orbital. They are 4dxy, 4dyz, 4dxz, 4dx squared minus y squared and 4dz squared. L equal to 3 means f orbital. The possible M values are minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. The possible f orbitals are 7 orientation because of we are having 7 M value. 4fx x squared minus 3y squared, 4fy x is 3x squared minus y squared, 4fz x squared minus y squared, 4fx y z, 4fxz squared, 4fyz squared, 4fz cube. So when you count this, we have total number of orbitals are 16. 7 plus 5 plus 3 plus 1 equal to 16. N equal to 4. How many orbitals are possible? 16 orbitals are possible. And question number 28. How many radial nodes for 2s, 4p, 5d and 4f orbitals exhibit? How many angular nodes? Radial nodes, angular nodes. The orbital given are 2s, 4p, 5d and 5f. The first one is principal quantum number 2, 4, 5 and 4. L azimuthal quantum number for s orbital L equal to 0, p orbital L equal to 1, d orbital L equal to 3 and for f orbital L equal to 3, d orbital 2. Radial node we can find from the formula n minus L minus 1. N value 2 minus 0 equal to 2, 2 minus 1 equal to 1. For second orbital, 4 minus 1 equal to 3, 3 minus 1 equal to 2. 5 minus 2 equal to 3, 3 minus 1 equal to 2. 4 minus 3 equal to 1, 1 minus 1 equal to 0. Angular node nothing but L value 0, 1, 2, 3. This is question number 28. Come to question number 29. The stabilization of a half-filled d orbitals is much more pronounced than that of p orbital. Why? Symmetry. The half-filled d orbitals are more symmetrical than partially filled orbital and this symmetry leads to greater stability. The second point is exchange energy. If two or more electrons with the same spin are present in degenerate orbital. Degenerate orbital means orbitals having same energy. Orbitals having same energy. That is a degenerate orbital. There is a possibility for exchanging their position. Their positions. During exchange process, the energy is released and the released energy is called exchange energy. If more number of exchanges are possible, more exchange energy is released. More number of exchanges are possible only in the case of half-filled and fully filled configuration. Now, this is D5 electronic configuration. Next one is P3 half-filled electronic configuration D5. Now, for D orbital, D5 orbital, how many exchanges are possible? For the first electron, 1, 2, 3, 4 exchanges are possible for the first electron. Second electron, 1, 2, 3 exchanges are possible. For the third electron, 2 exchanges are possible. For the fourth electron, 1 exchanges. 4 plus 3 plus 2 plus 1. In D orbital, there are 10 exchanges are possible. Therefore, exchange energy is more, it is more stable. Come to P orbital, half-filled P orbital means P3. For the first electron, 2 exchanges are possible. For the second electron, only 1 exchange is possible. 2 plus 1 equal to, for P orbital, only 3 exchanges are possible. Therefore, the half-filled electronic configurations are more stable than partially filled electronic configuration. Question number 30. Consider the following electronic arrangement for the D5 configuration. This is D5, D5, D5. Which of these represent the ground state and which configuration has maximum exchange energy? Remember, filling of this orbital and these orbitals are wrong. So, according to Hund's rule, first we have to fill unpaired electron 1, 2, 3, 4, 5. After that only pairing takes place. According to Hund's rule, this filling of electron is incorrect. Here also, here vacant orbital is present but the electrons are paired here. Incorrect electronic configuration. We have to fill the electron like 1, 2, 3, 4, 5. After all the orbital containing 1 electron in each, the electron is paired with the first electron. D5, all these are D5. Here half-filled electronic configuration, 5 electrons are present. Ground state electronic configuration is, this is D5. Maximum exchange energy is given by this D5 electronic configuration. There are 10 exchanges are possible for D5 electronic configuration. So, maximum exchange energy is for D5. Come to question number 31. State and explain Pauli exclusion principle. Pauli exclusion principle states that no 2 electrons in an atom can have the same set of values of all 4 quantum numbers. Helium atomic number 2 electronic configuration 1s2. 1s orbital containing 2 electrons. When we write in box form, s orbital has only one orientation. Therefore, there is only one compartment for 1s orbital. It has 2 electrons in s orbital, 1 electron, another electron like this. For the first electron, n value equal to 1, s orbital, L value equal to 0. If L value equal to 0, m value equal to 0. The first electron has plus half clockwise spin. The second electron, n value equal to 1. For s orbital, L equal to 0. If L equal to 0, m equal to 0. For the second electron, s value is minus half. First electron plus half, second electron minus half. So, no 2 electrons in an atom can have the same set of values for all the quantum number. They change in the spin quantum number. One electron spin in clockwise direction, another electron spin in anti-clockwise direction. Come to question number 32. Define orbital. What are the n and l values for 3px and 4d x squared minus y squared electron? Orbital is a 3-dimensional space in which the probability of finding the electron is maximum is called orbital. For the orbital 3px, n value equal to 3, for p orbital l value equal to 1. For 4d x squared minus y squared, n value equal to 4, for d orbital l value equal to 2. Come to the important question. Explain briefly the time independent Schrodinger wave equation. Erwin Schrodinger expressed the wave nature of electron in terms of a differential equation. This equation determines the change of wave function in space depending on the field of force in which the electron moves. The time independent Schrodinger equation can be expressed as h cap psi equal to E psi, where h cap is called Hamiltonian operator, psi is the wave function and is a function of position coordinates of the particle and is denoted as psi x, y, z, and E is the energy of the system. The Hamiltonian operator is given as minus h square divided by 8 pi squared m into dou squared by dou x squared plus dou squared by dou y squared plus dou squared by dou z squared plus v. On substituting Hamiltonian operator in the first equation, minus h square divided by 8 pi squared m into dou squared psi by dou x squared, dou squared psi by dou y squared plus dou squared psi by dou z squared plus v into psi equal to E psi. Multiply by minus the reciprocal quantity of this minus 8 pi squared m divided by h squared and rearranging dou squared psi by dou x squared, dou squared psi by dou y squared, dou squared psi by dou z squared plus 8 pi squared m divided by h squared E minus v into psi equal to 0. The above Schrodinger wave equation does not contain time as a variable and is referred to as time independent Schrodinger wave equation. So, in this we have discussed from question number 26 to question number 33. In the incoming video, we continue these important questions from Unit 2. Thank you for watching. If you like, please subscribe. Thank you very much.